In this video, I want to talk about solving linear equations with variables on both sides. So this is a lot like the last few videos that I've done, except for now we have x on the left side and on the right side. That's going to change a few things. So let's look at it. This example, we have 2x plus 3 equals 5x minus 9. Now, something I want to do, just do sold vision real quick and show you the like terms. This is kind of how I see it. So you have 2x and 5x, as well as plus 3 and minus 9. So you can see with those different colors, 2x and 5x, those are like terms. And 3 and negative 9 are also like terms. So what would it look like if we just simplify this equation, or maybe not simplify is not the right term, but if we changed the equation to where it's still equivalent, but we have all of our like terms on the same side. So I want all my x's on one side and then all of my constants on another. So that would mean maybe subtracting 2x from both sides. This is going to get real hard with the color. So then that leaves plus 3 over here, or maybe we can just write 3, is equal to 5x minus 2x is 3x minus 9. And then we would add 3 to both sides, or add 9, sorry, to both sides. And that leaves me with 12 over here equals 3x. Okay, and then I just want to solve for x, right? Get x by itself. So divide both sides by 3. And 12 divided by 3, then we can just write it this way. I guess we'll write it in our original orange. 12 divided by 3 is 4, and 3 divided by 3 is x. So that is my final answer. X equals 4. So this is really similar to one-step, two-step equations. It's just that making sure that you have your x's on one side and your constants on another. Let's look at another example, maybe a little more complicated. Okay, this time I have 4 times x plus 2 in parentheses equals 3 times 2x minus 4 in parentheses. So we could look to divide, but it doesn't look like dividing 4 or dividing 3 on either side is really going to help. So then I need to simplify both sides, just like in a multi-step equation where you would simplify both sides before I start trying to move things around. So let's try that here. If I distribute the 4, then that gives me 4x plus 8 equals, and now let's distribute the 3 as well. 6x minus 12. Okay, again, I'm going to try to do less colors this time, but let's use orange and, I don't know, blue. How about pink? Okay, so here's my x's, 4x and 6x plus 8 minus 12, right? Those two are equal to each other. Okay, so again, here's my like terms, 4x and 6x, positive 8 and negative 12. And be careful with those negative signs. Just don't leave them out, okay? Don't let them get lonely. They're negative enough as it is. Okay, so on that note, again, like I said, I like to try to keep my numbers positive if I can. You don't have to do that. So subtracting 4x on each side gives me 8 equals 2x minus 12. Add 12 to both sides. So then I have 20 equals 2x. Divide both sides by 2. We get x equals, or sorry, should say 10 equals x. Which, if it makes you feel better, you can write x equals 10, right? So that's the answer. So simplifying first and then going further. Okay, one more example, real quick today. Okay, so this one, wow, there's a lot going on. 1/3 times 2x plus 3 equals 5 plus 2 times x minus 6. So we want to simplify both sides. Now, here's where I'm kind of a little cautious. If I ever see a fraction, I really like to stay away from fractions. It just makes my life easier. So I'm going to leave this side as it is for now, because it's 1/3 times this whole thing. So I'm just going to leave that side. Let's see if we can simplify this side over here. So I need to distribute the 2 right there, and we can distribute it there. So that leaves me with 5 plus 2x minus 12. And then simplifying that again, 5, okay, so maybe let's do some, we can do solve vision, I don't mind. We have 5 plus 2x minus 12, right? These are my like terms that I can combine over there. 5 minus 12 is negative 7, so we're left with 2x minus 7. Okay, and that's why it's important for us to keep that negative, because otherwise we might forget that it's negative 12 instead of just 12. Okay, so now there's 2 options. I could distribute that 1/3, but that would give me 2/3 x and 1. Or what might it look like? And I'll go ahead and do solve vision this side as well, right? If you, well, no, we'll leave it for now. We'll just hold on for just a sec, right? Instead of distributing that 1/3, what if I multiplied both sides by 3? Right? Or divided, you could think of it as dividing by 1/3, but that's the same as multiplying this side by 3 and this side times 3. Because what that does is it allows me to cancel out over here. Those 3's go away. And then I just distribute the 3 over here. And that's a lot easier than dealing with fractions, at least in my opinion. So now we'll get some solve vision. 2x plus 3 equals 6x minus 21. Okay, again, and this has all worked out really nice that both sides have been positive, but I do like to keep my numbers positive if I can. Plus 21 on both sides. And if you, maybe you don't like doing that. Maybe you would rather subtract 3 and subtract 6x. That's totally fine. So we did that. That leaves us with, and I'm kind of moving up here, 2x, 3 plus 21 is 24, equals 6x, and that's it. Okay, now we can subtract 2x from both sides. And we're left with 24 equals 4x. Not done though, because getting x by itself would mean I have to divide by 4. Hopefully you can still see this okay. Dividing by 4 would leave me with, those 4's cancel, 6, 24 divided by 4 is 6, equals x, and that is the answer. So that x is 6. So, all that being said, this is a lot like solving two-step or multi-step equations. Just make sure that your x's or your variables end up on one side and your constants end up on another. And that's how it's going to be the easiest to solve problems like this.